Hello everyone, Patrick here. You know me as Rig Papa on the Vera community forums. Well, I was going to make this video about creating a motion controlled light. And then I realized before I dive into creating a motion controlled light, I better say something about groups, condition groups, and the logic that goes on with condition groups, because that's actually a fairly important subject. And of course, I'm going to have to create some groups in our motion controlled light. And it would just be better if I explained that beforehand. So let's dive into groups and talk a little bit about that. As always here, hang on one moment. There we go. So I've got my setup here. What I've done is I've set up with 3 virtual switches that we can play with. And I've got my reactor sensor, my new reactor sensor here ready to go. And I'm going to go in there and I'm going to go into configuration, and the first thing I'm going to do, I'm going to leave this comment for the moment. I'm just going to go ahead and create a new group. So you'll notice this background, this sort of beigey background, is different from the blue. That's because the blue background is the root group. It's the container group for all conditions in this reactor sensor. And what we've just done here is we've created a subgroup in it, right? So and we even have a button in this group so we can create a subgroup in here. So we can nest these groups. They nest one inside another. But I've created this group inside the other group. Now, I'm going to leave this group with an AND condition, and I'm going to put device state conditions in here for my virtual switch 1 is turned on, and device state for virtual switch 2 is turned on, and device state for virtual switch 3 is turned on. Okay? All right, so I've now got a subgroup here. I'm going to call this group A, like that. I'm just going to rename it and call it group A. So I've now got this subgroup called group A. And it is an AND group, a logical AND. So in order for this group to be true, the AND operator means that all of the conditions inside it have to be true. Let's save this and look at this in the status view. Okay, in the status view, we see that our root group, the top level group, that's the container for everything, it's itself an AND group right now. We can change it, but we're going to leave it right now as an AND group. We've got a comment in there. It doesn't make a contribution to the logic. It's just for documentation purposes to remind you of what you're doing. And then we have our group A, which contains these 3 conditions: virtual switch 1, virtual switch 2, virtual switch 3, all testing to see if they're on. Let's turn on one of our virtual switches here. And we see when we turn on one of our virtual switches, it illuminates green in the status panel to show us that the condition has gone true. Okay, but the AND, notice the AND here is still blue next to the group. It hasn't changed. That's because this group is false. The state of this group is false. We have not yet met the AND condition, which is that all 3 of these conditions needs to be met. Let's go turn on the other 2 switches. There's one, there's the other, and look what happened there. As soon as the 3rd switch came on, this changed state to green, changed color to green, and the state became true here on this group. And likewise, the root group became true, because basically the root group has only one condition in it, which is this group. So when this group went true, the root group went true as well. So that's an AND. All 3 conditions have been met. That's an AND. So if I was to turn one of these off, let's say I turn off number 1, as soon as I turn off number 1, everything goes false. Okay? So that's because we're no longer meeting that condition of this and this and this have to be true. All 3 have to be true. Okay, let me go back in here. Let's create another group at this level. And I'm going to call this group B, and I'm going to leave the other group just because it's kind of handy to see what's going on in there, and I'm just going to quickly reproduce everything that's been done in the other group Gee, Patrick, maybe you need to implement a copy for one to the other, huh? How would that be? Maybe that sounds like a good idea. So, virtual sensor number 3. It's funny because I don't think that's actually something that people will do that much, but yeah, you never know. Okay, now this one, so look, these two groups are now identical, right? They're completely identical. I'm looking at devices 8, 9, and 10, virtual switch 1, 2, and 3, in this group A, and I'm looking and making the same tests down here in this group B, but here I'm going to set it to OR. All right, so now I've got it set to OR. So group A is AND, and group B is OR. Let's go back out here and look at what goes on. Okay, so right away, we've got some lights on here. Let me turn all the switches back off. Okay, so we're starting with a clean slate now. All 3 virtual switches are off, and as we can see, our group A, the AND group, it is false right now. Its state is false because these 3 switches are not on. Group B, our OR group, is also false. It has the same conditions. The OR group will be true when any one of the switches, this or this or this, is true. All right, so if I turn on any one, I'm just going to choose virtual switch 2 here. If I turn on virtual switch 2, we can see that both of these tests, they're identical tests, both of these tests has gone true, but the AND group condition hasn't been met yet, whereas the OR group condition has. So, and that's green. And now, the AND didn't go green up here because this group isn't true. This is an AND, which means this and this have to be true, connected by this line here, right? In order for this to be true, this and this have to be true, okay? So that's an OR group. And if we keep turning on switches, the OR group stays true, but then when finally the third group comes on, the third switch comes on, that's when the AND group also comes true. And now that both group A and group B are true because our root group is an AND, when both of our subgroups are true, then the root group goes true. Now, something else I didn't mention when we were just looking at group A, the AND group, that I'll mention now is you might have also noticed down here when the root group went true, the highlight here went from reset to trip. From the reactor sensor itself went from reset to tripped, or from untripped to tripped. The reason these things are called reactor sensors is that they implement the behavior of a security sensor. They can be tripped or untripped. A security sensor is a binary sensor. So that would be like a motion sensor or a door sensor or what have you. And in Reactor version 1, when I first imagined Reactor, all I was really imagining was that it would be an advanced triggering mechanism for Vera scenes. So one of the easiest way to trigger a Vera scenes is to look at the state of a sensor. Right? Is the sensor tripped or untripped, and have the scene do whatever it needs to do, or 2 scenes do what they need to do, one for tripped, one for untripped. So when I implemented the first version of Reactor, I implemented these objects as security sensors. I implemented them with the behavior of a security sensor, of a binary sensor. Since that time, beginning in Reactor version 2, Reactor version 2 had its own activities, which are basically the actions that you also see in scenes, but it's amped up a little bit from what's available in scenes. So all of a sudden, having it be a scene trigger wasn't quite as necessary. You could run activities directly in Reactor. But I kept this notion of tripped and untripped, because of course I wanted everybody who had written scenes and triggers for version 1, I wanted version 2 to be compatible with that, to be backward compatible. So to this day, and probably forevermore, these things will be called reactor sensors, and they will manipulate this tripped or untripped state based on the state of the root group. When the root group is true, the reactor sensor will be tripped, and when the root group is false, the reactor sensor will be untripped. But in practice, we may or may not actually need to use the tripped and untripped state anymore, because now you can have activities on individual groups, and you have more fine-grained control of what activities you can run. Maybe that's a little bit too much information, maybe a little confusing right now. I apologize if it is, but I wanted you to have that background and explain a little bit what's going on. Okay, we've got one more here. that we're going to look at. Well, really two more, but we're only going to look at one more. I'm going to reproduce this group again, and we're going to do device state, and virtual switch 1 is on. Oh, and we're going to look at one other mode too. And we're going to do device state virtual switch 2 is on, and finally we're going to do device state virtual switch 3 is on. Thank you very much. And we're going to make this an XOR. Okay, and I'm going to go over to my other monitor here, and I'm just going to quickly turn off all the virtual switches so we start with a clean slate. Okay, and then I'm going to save. And now let's go back to the status tab and look at where we are. And oh, you know what? I'm going to quickly go, and just for consistency's sake, I'm going to rename this group. I click on here, and I'm going to call this group C, just for consistency's sake. Save. And now I can go back over to status. Okay, so now we can see our three groups on the screen. We've got our AND group A, our OR group B, and our XOR group C. XOR means exclusive OR. There's some disagreement about what exclusive OR with multiple inputs means, but in Reactor I've taken the meaning that exclusive OR means exclusively one across all of the conditions. So in this case, XOR means if one and only one of these conditions is true. May not be something you use very often, but I want you to see it in action. So let me turn on. Everything is off right now. All of our groups are false, as you can see. So let me turn on one switch. I'm going to turn on switch 3 this time. And you can see in each of the groups, switch 3's test has gone true. And in the AND group, we're not there yet because we haven't met the conditions of all three, right? So that's fine. In the OR group, we're true because any one of these is true. Number 3 is true. That's fine. And in the XOR group, we're true because exactly one group is true, right? So good. Okay, let's turn on another one. I'm going to turn on switch 1. And now with switch 1 on, you can see our AND group is still off. Our OR group is still on because we have at least one of the conditions met. But the XOR group has now gone off because we have two conditions met. XOR only allows one of the conditions to be met. Exclusive OR, either or. So that's how XOR works. And of course, if we turn on the final second switch 2 rather, then our AND group is now met. Our OR group is still met because, you know, one or more, all of them is still more than one, and then, or at least one, and then XOR we're still false because we have more than one on. So that's that. Okay, back up one step real quick. I want to invert one of these. Actually, let's invert a couple of these. Let's just invert the AND for fun right now and go back. And I'm going to turn off, before I go back into the status display, I'm going to turn off all my switches again. Okay, so now let's review before I go back to status. For group A, I have not AND. Okay, actually, let me do this. For group B, I'm going to have not OR. And I'm just going to disable group C. Let's not worry about that right now. I'm just going to mute group C so it doesn't make a contribution here. So now you see by disabling group C, it's all gray, which means those conditions are not going to execute. And any result of these conditions is not going to affect the overall root group, right? It's not going to make a contribution to the parent conditions. So look here, none of my conditions is met in our AND group, but it's inverted. So now it says not AND here, because this is false. This would normally be false. If this was AND, this would just be false because all three of these conditions aren't met. But by making it not AND, it flips it. So instead of being false, it's true. The same thing with the OR. One of these, at least one of these, has to be on for this group to be true, but they're all off. So this would normally be false if it was just plain OR, but as not OR, it's true. I'm going to turn one of the switches on. There we are. Now, The OR is now, the basic OR is now true because we have one of the switches on. But because we made it a not OR, the group state is false. So this not just inverts the sense of the test, right? This is still true because we haven't met all three conditions here. When we turn on the other two switches and all three are on, then this and, if this was and, it would be true at this point, but because it's not and, not true is false. So this group is now false. So that's the effect of not. It inverts the sense of the test. Sometimes it's helpful to do that. Sometimes it's easier to write a piece of logic that involves multiple conditions as the inverse of what you're really trying to get to, and then just flip the last answer at the last minute, which is exactly what this does. Okay, so that's basically covering the basics of logic with groups. Why do we want to do this? Why is this important? I'm going to just get rid of this XOR group altogether at this point. I'm going to get rid of this OR group altogether at this point. Let us imagine, why is it important to have this and why is it important to have nesting of groups? Let's imagine that we want to have a condition where in order for the condition to be true, switch 1 has to be on, and either of switch 2 or 3 has to be on. Doesn't matter if it's 2 or 3 or both, but 1 must be on, and either 2 or 3 has to be on. How do we represent that here? Well, we have an AND group right now that requires all 3 to be on. That's not what we want. We want to handle the condition where 2 is on and 3 is off, or 3 is on and 2 is off. How do we do that? Well, we can add a subgroup. And we can say OR, and we can drag our conditions for 2 and 3 into this subgroup we've created. And now, what we've done, I'm going to hit save. What we've done, and I'm going to get rid of this comment at this point too, just because it's kind of getting in the way. So now what we've done is we've created a group. Group A will now only be true, I'll rename this 2 or 3. Group A will only be true, it's an AND group, when both of its conditions are met. What are its two conditions? Well, its two conditions are this, you can see the little bar here, are this device state condition for switch 1 has to be on, and its other condition is this entire green backgrounded group, our 2 or 3 group, right? And this is OR. This will be true when either one of these switches is on. So maybe you're a little confused. Let's go look at the state of this. Oh, I have unsaved changes. There. Let's go look at the state of this. Now I got to turn all these switches off so we can start from a clean slate. Okay, so let me not worry about switch 1 right now. Let's just focus on switch 2. Let's look at what happens with switch 2 and switch 3. If I turn on switch 2, we already learned that in an OR group, if one of the switches is on, then the group will be true. So here we have switch 2 is on, so this group has gone true. Okay, fine. If we turn switch 2 off and turn switch 3 on, the group is still true because at least one of these is true. And in fact, if we turn switch 2 back on, that's still true, of course, because it's OR, this or that. Both is fine. So I'm going to turn 2 off again. So now we have 3 on, 2 off, and our original logic that we said we wanted to implement was when switch 1 is on and either 2 or 3 is on. Okay, so we have 2 or 3 on, in fact number 3. So let's turn on number 1 and see what happens. Boom. Switch 1 came on, the test came on, so group A went true. And because the only condition inside of the root group now is group A, the root group also went true. So we could actually promote this whole thing up and just make it all inside the root group. But because we have the group there, I just made it that way. But anyway, the point being, if I switch now 2 off, or 2 on rather, and 3 off, everything remains true. But if I switch 2 off, okay, so our logic, remember our logic was 1 is on and either 2 or 3 have to be on. So when I switch 2 off so that 2 and 3 aren't on, now the whole thing goes false again, right? The sensor itself untrips because group A went false, and because group A went false, the root group went false, and because the root group went false, the sensor untripped. So switch A is still true, but that's not enough. We haven't met the OR condition of these 2 down here. And so that's the value of having these nested groups, is that you can, if you think about your logic a little bit, you can break it down into, I need this and this and this, and this or this, or I need this and this, or this and this, and there's a lot of different ways to do it. And then Boolean logic is a whole subject unto itself, and you know, and sort of boiling it down to its simplest form is an art form, really, that a lot of electrical engineers, for example, are really good at. But it's something you're going to have to adapt to and just sort of slowly wrap your head around and experiment with. And I encourage you to use the status view a lot. But anyway, I hope this has given you a little overview of groups and how groups work, and how you can use groups to make logical, you know, as your building blocks of logical connections between device states or other conditions, and accumulate those into more complicated, complicated Boolean expressions, logical expressions. All right. So now, next video, we're going to talk about creating a motion-controlled light with and without delays. Again, my name is Patrick. You will find me as RigPapa, R-I-G-P-A-P-A, over on the Vera community forums. If this video is helpful to you, please give me a thumbs up. And if you want to know when new videos come out, hit that subscribe button and even the little bell next to the subscribe button. If you have comments about something in this video, you know, about the video in general, feel free to make them here in the YouTube comments. But if you have questions about Reactor, or if you have a suggestion for a future video or something like that, I prefer you make those over in the community forums, the Vera community forums, at community.getvera.com. And again, I'm Patrick. You'll find me there as RigPapa, R-I-G-P-A-P-A, and I will see you next time. Thanks.